Hey everybody. It was warm today. Not crazy warm, but you know, August in New York, it gets pretty warm. So I was just wondering, I've got some friends in Europe and they use Celsius temperatures, and whenever I look up the temperature over here, everyone talks about Fahrenheit. All right, so let me show you what I mean. Let's take a look here. Yep, there it is. Looked it up and we see the temperature 85 degrees Fahrenheit, right? Well, how do we convert that to Celsius? Well, I could click that button on the screen, but this is a math class. That's too easy. Let's figure out how to do it on our own. How does that button work? What does the computer do? So that's what we're going to do here. All right, we're going to do this by solving a linear equation, and that's what this video is about, solving linear equations. So let me first take you to another website here, which has a nice little example for us. So a linear equation is an equation of the most simple type, essentially. No squares on the x, no square roots, no trig functions or any crazy other functions going on. It's the simplest kind of equation. So here's one, and let's think about what we might do to solve it. Let me first set this equation up by depicting it on this scale that we see. We can think of an equals sign as meaning that the scale is balanced. Equals means the same. So if the quantity on the left is the same as the quantity on the right, then the scale should be balanced. So let's load up this scale, all right? So we see 4x on the left. So let me drop 4x's over there. There goes the scale off kilter because I put too much on one side. And we got 2x's on the right, and we've got 8 ones. All right, because plus 8 means you're adding 1 8 times. So let's keep plopping those on there. One more. Oops, is it not letting me do it? There it goes. Okay, so the scale is balanced, right? Because that's what the equation says. It says that 4x's is the same as, equals, 2x's plus 8 ones. All right, so the scale has to be balanced. Now, how would we solve for x? I want to know, how much does x weigh? All right, well, how would you do this? If you physically had this scale in front of you, how would you figure it out? Well, think about it. Pause the video. Okay? And then you've come back, you've thought about it, you've figured it out, right? So what are we going to do? We're going to start removing things from this scale until we've isolated the x on one side and the ones on the other side, and then we'll know how much the x weighs, right? So I can keep the scale balanced provided I remove the same amount from both sides, right? So the scale will stay balanced if I remove an x from both the left and the right. I've removed the same amount, so the scale should stay balanced, right? So I'll remove an x from the left. Oop, didn't mean to put it onto the right. And I'll move an x from the right, right? And sure enough, scale is balanced. Let's do it again. Remove an x from the left, remove an x from the right. The scale's balanced still. Okay, so I've got only x's on the left, only ones on the right. I think I'm getting there. I'm almost to where I need to be. What I need to do here is have only one x on the left. If I have only one x on the left, then I'll know exactly what it weighs. I'll just look at the number of ones on the other side. Well, if I have two x's, I want to get half of that to get one x. So let's cut it in half. I'll take half of the x's away, and I'll take half of the ones away. There's 8 ones, so I'm taking 4 away. I'm dividing by 2, right? And there it is, it's balanced. And so do we see how much the x weighs? Sure enough, the x is the same as 4 ones. So we've solved the equation, x equals 4. This is how algebra works. This is exactly how algebra works. It's just balancing a scale. All right? Let's do this problem, this exact same problem, by hand, without thinking about a scale. All right? So what was the problem? It was 4x equals 2x plus 8. Okay, here we go. 4x equals 2x plus 8. What was our first move? Our first move was to start removing x's. So I subtracted an x from the left and I subtracted an x from the right. Removed an x from each side of the scale. And I did that twice. So what I did is I subtracted 2 x's from each side. And when I did that, I was left with 2 x's on the left and no x's on the right. They were all gone. So I got to here. And then what did we do? We said that, well, we want to get just 1 x on the left. So I took half of each side. So I removed one of the x's. I divided by 2. And I removed half of the 8. I divided that by 2. And what did we end up with? X equals 4. And that was our answer. So what is the trick here? The trick is that we can do anything we want to this equation, provided we do the same thing to both sides. Okay? Almost everything. There's some things that aren't allowed, all right? But for now, essentially, almost everything, anything. So we can subtract, as long as if we want to subtract something, fine, just do it to both sides. If you want to divide, fine, just make sure you do it to both sides, the same thing. It's got to be the same number. If you keep doing this, you do it the right way, you get to the answer. And so this is how you solve a linear equation. Okay, so let's deal with that problem that I started this video out on, finding the temperature in Celsius, right? So let's go back and take a look. What was our temperature? Our temperature is 85 Fahrenheit. How do we get that into Celsius? Well, I happen to know the equation that relates Fahrenheit to Celsius. And you know what? You know what kind of equation it is? Happens to be a linear equation. So you can look it up, and this is what it is. Okay? The equation relating Fahrenheit to Celsius. All right? It is this. Fahrenheit temperature equals 9/5 times the Celsius temperature. Give me a second. I need a new pen. I think that pen just died. Good timing, pen. Plus 32. All right. Fahrenheit equals 9/5 Celsius plus 32. What's the temperature today? It's 85 Fahrenheit. So I want to solve this equation. Okay, so let's do it. Let me move my camera a little bit here. Okay. So what can we do to solve an equation? We could do whatever algebraic operation we want. We just have to do the same thing to both sides. So, I want the variable that I'm solving for to be all by itself so that I can compare it to the other side. So I want to get rid of the 9/5 and I want to get rid of the 32. What did we do last time? We subtracted. Let's subtract, all right? In general, always better to subtract or add before you multiply or divide. Keep that in mind. Always better to add or subtract before to multiply or divide. Almost always. But it's a general rule, it works. All right, so let's subtract 32 from both sides. That will keep this scale balanced because I removed the same amount from both sides. All right, so if I subtracted the 32 that was here, well, it's gone now. If I have 85 and subtract 32, what am I left with? 53. So I'm just left with this, a new equation. Scale's still balanced because I did the same thing to both sides. So what do I do now? Well, this one's a little bit trickier. I got a fraction. Well, what makes a fraction a fraction? The denominator. If there's no denominator, there's no fraction, right? So let's get rid of that denominator. How do you get rid of a denominator? You multiply by the same thing. So I'm going to multiply this by 5. Now, if I do it to the right side of the equation, have to do it to the left. Now, like I said, if you divide by 5 and then multiply by 5, you undo that thing, right? So what happens to the left? 5 times 53, 165. If you have to think about that a little longer, don't worry about it. You know, you might have to go off to the side, do a little bit of long multiplication, right? So 3 times 5 is 15. 5 times 5 is 25. Looks like I got it wrong. Okay, 265. There we go. Good. Good thing I checked, right? Always good to work things out, right? So 265. So now we have this equation. All right, so what are we going to do? I want to get rid of the 9. Well, if you multiply by 9, to get rid of it is to do the opposite. So I'll divide by 9. In other words, another way to think about it, I have 9 C's on that side of the scale. To get 1 C, I want 1/9. So I'm dividing by 9. Okay? So there we are. And so these, now I'm just left with 1 C, right? In other words, those cancel. And C equals 265 divided by 9. Okay? What is that as a decimal? Let's go ahead and compute that. Let's go do a little bit of long division here. How many times does 9 go into 26? Twice. 2 times 9 is 18. 26 minus 18 is what? 8. Drop the 5. How many times does 9 go into 85? 9 times. 9 times 9 is 81. Subtract. Now, are we done? No, we can go further if we put a 0.0 here. Drop the 0. How many times does 9 go into 40? It goes in there 4 times. 4 times 9 is 36. Now I see a pattern, right? I'm getting 4 again. So what I'm going to do, drop another 0, and this pattern's just going to repeat. So I'm just going to keep getting 4, 4, 4, 4, 4, 4, 4. To denote that the pattern repeats, I draw a little line above it. So that's it, right? C equals 29.44. And there we have it, the temperature in Celsius. So when you talk to your friend over in Europe, and you want to tell them, you don't want to say 85 degrees over here because they may not know what you're talking about, you'll tell them 29.4 degrees if you want to be really precise, or 29.44 if you want to be really, really precise. All right? So we'll look at some other more complicated linear equations in the next video, but that's it for this one. So, so I will see you then.